Hello students, I am Dr.V Deshpande, Head Department of Physics, Shivaji Arts Commerce Science College Kannada. Now your today's topic is the specific heat of solids. Now in 12th class you know about the first law of thermodynamics, that is heat is supplied to any body which is utilized into two parts. One is change in its internal energy and other part will be doing some work. That is dq is given by dE plus pdv, where pdv is the work done. Now E is except for arbitrary constant determined uniquely by the temperature and volume of the systems. Hence dE is given by, which is equal to dou E by dou T at volume V into dt plus dou E by dou V at T into dV, which may be written in the form of dq is equal to dou E by dou T at V into dt plus in bracket dou E by dou V at T plus P into dV. Now there are two specific heat of solids. One is specific heat at constant volume, which is given by dq by dt at constant volume, which is equal to dou E by dou T at constant volume. Now in general you know there are two types of specific heat. One is specific heat at constant pressure, another is specific heat at constant volume. Now this is Mayer's relation, which is called as Cp minus Cv is equal to R, or R is the universal gas constant. Now this is the graph which shows temperature versus C in calorie per mole per degree, and here is Cp, that is specific heat at constant pressure, and here is specific heat at constant volume. And in general you know that Cp minus Cv is always greater than 0, means that Cp minus Cv, its value is always positive. Now in this case there are various theories of lattice specific heat. Now the vibrational, let us consider number of the atoms may be expressed as energy of n harmonic oscillators, which has in the form of chain of n capital N atoms. Extending the arguments employed, there are three-dimensional case. One is led to conclusion that the vibrational energy of a crystal containing n atoms, which is equivalent with the energy of a system of 3n harmonic oscillators. These features is common to all theories of specific heat, and distinction between the various theories based on their differences in the proposed frequency spectrum of the oscillators. The central problem in the theory of specific heat is therefore calculation of the wavelength and frequencies of the possible modes of vibrations of the crystal under the consideration, that is called as harmonic oscillators. Okay, now the classical theory of specific heat. Now the energy of harmonic oscillator of natural angular frequency, that is omega, may be written as energy is given by E is equal to p square upon twice m plus m omega square q square by 2, where the first term on the right represents the kinetic energy, p is the momentum, and the second term represents the potential energy, that is this is the kinetic energy totally and this is potential energy, where q is the direction Q is the direction deflection from the equilibrium position. It is well known that the average energy of harmonic oscillator, according to classical statistical mechanics, it is expectation value of energy E is equal to integration from 0 to infinity epsilon e to the power minus epsilon by kt dE, which is equal to divided by 0 to infinity e to the power minus e by kt into dE, which is equal to kt, where k is Boltzmann constant and T is absolute temperature and K is Boltzmann constant. It is important to note that the frequency does not enter in the result. In other words, the vibrational energy of a crystal of capital N atoms is classically always equal to E is equal to 3 nkt. Now, independent of the assumed frequency distribution of the oscillators used in the model. Now, as long as the volume of the solid is kept constant, it is only temperature dependent contribution to the total energy of the system. Thus, for solids containing one type of atoms and putting capital N equal to the number of the Avogadro's numbers contains for the specific heat per gram. Therefore, Cv is equal to, that is, dou E by dou T, that is 3 Nk. Now Nk is equal to R, that is a universal gas constant, and putting this value we get, which is equal to 5.96 calorie per degree per mole, means that the specific heat of all solids at constant volume is classically nearly equal to constant, and which value is equal to nearly equal to 6. This is called as specific heat of solids.